So here we have this problem, and the idea you have this cat, and that in essence that's how they actually do their hunting purposes. They're that's something that is instinctively ingrained in their brain. What does instinct mean? Do you have to teach that to the animal? No, they're born with that knowledge inside their head already. So a cat would instinctively pounce on what the mom would teach you. In this case, it's a mouse. Okay, and at 13.33 kilograms per meter per second, which means that number is a what? It's a momentum. We'll come back to that. And the mass of the cat is 6.20 kilograms, okay? So that's pretty simple. It's telling you what the mass is. The elapsed time was 0.71 seconds. That's true. And is moving at 1.91 meters per second squared. Careful when you look at that variable. Why is that? Because that is an acceleration. It's not a velocity. Because you're constantly moving with velocity and acceleration. It's just the rate that you're moving. So it's kind of a vague term when you say moving at either a velocity or an acceleration. So now, for every problem that you solve for up till this point, you've always been solving for which one usually? What kind though? Final velocity. Well, what's this question asking though? Initial. So what this is saying, okay, you maybe have this cat creeping up in the pasture or wherever it is it's doing its hunting, and sometimes it could be one of these things to where it's crouching and all of a sudden turns and looks because it heard something and then jumps on the mouse and starts shredding it up and tearing it apart. I don't know, that just sounds good. Some people hate mice. Is that anybody in here? Yeah? Okay, fair enough. But one of the things that, the reason I say it is it might change with some of the hunting, want to say behaviors of these animals. It wouldn't be just for like cats. Like Jerry back there, that's what that owl's name is Jerry. And the first year that was put up, I just let the zoology class pick the name. I said, so what do we want to call that? And the student turned around, Jerry. So we call him Jerry. Okay? There's a what named Jerry? Really? I usually just attribute to the cat. Or no, that's Tom. Jerry's the cat.
Jerry's the mouse. Tom's the cat.
Tom, okay, so I was right the first time. Anyway, what's kind of unique about owls, when do you typically see them? At night. And you're not going to see them, you're only going to hear them. So if they're going to hunt, can they rely on sight? Not unless they had UV, unless they could see ultraviolet light, which they can't. But the idea behind that, the reason an owl looks the way that it does, is if you could strip all the feathers off, the ears are actually offset a little bit. One's actually higher, the opening, just like what we have ear canals. One's a little higher than the other. So what happens is if the sound reaches this one before this one, it knows it's to the left, okay? And then if it reaches from the bottom and the top, it's also cupped that way, then it knows if that sounds below or above. That's kind of a little unique deal on why an owl looks the way it does. Anyway, getting back to this. You've read the problem. The next course, because this isn't going to be a one-step process to solve for this. But anyway, you've read the problem. Next thing you should do is what? And that is what? Okay, so what variable do you want to use for momentum? P, we said P, 13.33 kilograms dash meter over seconds. What else do we know? Okay. What else do we know? We know anything else? Yep. So you got to pay attention to that little guy. So, so what is the question ultimately asking though? The initial velocity. So where is the only place you see a variable for initial velocity? In what formula? The acceleration formula. So that means with those four variables in that acceleration formula, you have to have three of them, right? Because you can't solve for one unknown with having only two of the three variables that you need. Okay? So when we look at this information, we know that we're looking for this initial velocity. Okay? That's true. But you correctly said the idea that, come back to that in just a moment. Yes. Oh. Okay.
I wanted to see who was actually taking notes and kind of get tired of this being.
Oh.
People don't take notes. Go ahead.
Oh. Well, they can always go back to the Science Channel too. It's being recorded.
There's other options.
There's other options, yeah.
I'll just take an observer.
Okay. So, as we said, there's four variables in that acceleration formula, correct? And you have to know three of them. But we only have two of those so far. So, what is your acceleration formula? And if you don't have these wrote down, you're really going to be glutton for punishment. Okay? I failed that. Okay? All over what? And what does that equal? Okay, so we put that box around here because we need to know this initial velocity. Again, we said there's four variables. How many of those variables do we know? Only two of them. Okay, but do we have enough information to solve for one of these two? Yeah. Okay, now here's the point we're getting at. Some of you, okay, are better at solving these than others. Okay, for instance, but even when it comes to playing your musical instrument or something as simple as hanging on to the football or trying not to airmail that serve across the net or getting over. Sometimes you have to practice that and work a little harder than other people. Okay, so with that, we still need to find this guy. Okay? But we know we can't do this because we've got too many unknowns up here. But when we look at some of this other information that we have, what does this guy tell you right there? It will, yes. Okay? That's why when we said, when we first started working on these problems, it is so important that you write down all this information that you know, so it's here. You're not looking up in the problem, so when you look at what you actually have, you can say, oh, the momentum formula is only three variables, and we know two of them. So if that is the case, we can take this answer, or excuse me, that equation, okay, and how would we solve for the final velocity with this equation? We're going to take 13, we're taking what you're saying and applying it to the problem. So 13.33, you would say your momentum equals what? Yeah, do we know the mass? 6.20, and we're looking for the final velocity. That's why the very first time you wrote that formula down, we said it's probably a good idea to put VF in there, so you don't ever start looking for the initial velocity instead. So, what is our final velocity then? Now, I would suggest you throw that label on there. Don't put meters per second squared, because then you're going to have an acceleration again. Okay? up to this point, left outside, are we on the bus? Left outside. Okay, left middle. Middle. Right middle. Right outside. Okay, very good. So now, look at this. We've got our acceleration. We just solved for our final velocity. We've got our time down here. So this is where, how many of you think that you have to work a little harder at algebra than other people? How many of you are good at algebra? Okay, so the problem with this, when you're doing your algebra problems, it's always going to say, like, solve for the unknown here. You just given numbers and a variable, you just solve for that. The only difference is here it's in a word problem. And it's probably, is the reading of the word, is it the reading of the word problem that is a little more difficult for you to do? For some people, I would guess that's probably true. Because not everyone is going to be A students in here. Not everyone's going to be B students in here. But with a good attitude and hard work, there's no reason that you can't at least get up to the higher end of that C plus and maybe be teeter-tottering on that B work. Okay, so now that we have this, how are we going to solve for that initial velocity? Because we can erase all of this now, because we really don't need that. So, what are we going to do with our acceleration, which is what value? Okay, and that equals what over what? Over, okay? So again, we solve for that final velocity, and that's why we plug that into that equation. So, with this, how can we get rid of that darn fraction? People, I honestly think when you look at this, you see a fraction, it's oh, God, I can't solve this. I hate fractions. Maybe I would probably say the same thing. But what is the simplest way to get rid of this darn fraction? You're exactly right. We've done that before, because are we changing this value of 1.91? No. And now that you see that two fractions, what can you do with them numbers? We can cross multiply them and get a nice linear equation. In other words, what is 1 times 2.15? And then what sign do we have here? Minus, and then we've got what left over? In other words, 1 times VI is just going to give you the same thing, VI. Okay? So now, what do we have? What are we going to do with these two numbers now? Okay? So what would you do? 1.91 times 0.71. Okay? So now we got this nice linear equation. How are we going to get this VI all by itself in algebraic terms? If this is a positive value on this side, how do we get rid of 2.15 on the left-hand side? Someone said it. You're going to subtract it. We can't divide because we're not multiplying here. You undo the multiplication with division. We're not dividing. We are subtracting. But in this case, if we subtract 2.15 from this side, what happens to them two numbers? It's going to be 0, or you could say they cancel each other out. So that's gone. But you did that on the left-hand side of the equation. You got to do that on the right-hand side. So if we take 2.15 from here, what's that going to give you? Negative 1. Okay, so we're negative VI equals negative 1.21. So you might be asking yourself, we can't have negative velocities, right? We said that in class. That maybe sound familiar. But there's just one little step that you can do yet. Okay? In other words, you can even do that on your calculator. What I'm saying is take negative 6, divide that by negative 1. You know how to do that in your calculator? Negative times a negative is positive. Also, a negative divided by a negative is positive. Is that something you may have learned in algebra yet or no? You did? Okay. So what we're saying is either look at it in Sutton's case or whoever you're more comfortable. What, this here? Oh, I thought you said 1.21. Oh, okay. But it's negative though? Okay. Okay. Fair enough. So you can do this one of two ways. You didn't, if you understand this, all you're doing is just switching the signs. You can divide this whole thing by negative 1, or you can say, I'm multiplying by negative 1. You really don't have to show this step unless you really want to say, I need to see this. But if you have a negative sign on both sides, these both then become positives. So this is a hiccup that causes some problems for students because they get to that negative sign and they go, well, I don't know what to do here further. Or they get it into this type of an equation and they don't know how to get that negative velocity or that minus VI or VI by itself. That's why we spend time with it now. So should you may have a problem with it, we can work on it together. We'll get through it. Okay? That was probably, how many of you thought, I would agree, this is probably pretty challenging. Who would say that? I would. Yeah? I would agree. Okay? So, for those, and some people, it just comes natural for them. And for those who didn't have their hands up, they probably have a pretty good grasp on this, and you can go talk to them about that. Okay? But that's where you individuals have to take that initiative to say, I need some help with this. You're going to talk to one of your classmates. You can talk to Ms. Doctor. You can come down and talk to myself, whatever you feel most comfortable with. But you're the one that's responsible for that. You need to take that initiative. Okay? Can we erase this? Yes? Okay. So this second problem here, okay, some of you had already taken the next step to this because we've seen a problem like this before. I think it was handed back on your homework. And if we just wanted to know what the speed was of this shaft, that's pretty simple, okay? But there's something that is not written here where you have to put some of these concepts together, okay? Just like looking for a variable that doesn't say acceleration is this. If it just gives you the label, you know it's the acceleration. If it just gives you the let's say a number in seconds, you know that that's the time. But in this case, what do we know about this problem? Yes, you are right. So we know that something is 9.8. So once you see that meters per second squared, we know that this is what? An acceleration. Okay? What else do we know in that problem? Which is what? Okay? So what do you suppose, and what we're going to say is this guy is 0, because when you're holding that over the top of that opening, you'll be just holding it like this, and it's not moving right now. So it has an initial velocity then of 0 until you drop it. In 1001, 1002, of course, unless you're having a stopwatch, you're not going to say, oh, I suppose that was 5.15 seconds. You probably just say like 5, but in this case, 5.15 seconds later, it hits the bottom. So we said one of the things is pretty easy solving for this guy because we have an acceleration of time and an initial velocity. We can solve for that final velocity pretty easily. But that's not what it's asking. When we say depth, what are we talking about when we say depth? Yeah, how far down is that? Okay, so like I said, there's about 3 or 4 of you who actually took that extra step and already know what the answer to that would be, which is good. It means you're already ahead of the game. Okay, there's nothing wrong with that. So, how are we going to solve for that final velocity first? Do we have to put 0, the initial velocity over there? No, you don't have to. But you can put minus 0 if you wanted, but it's not going to change anything. So just like what we did the last problem, what are you going to do to get that VF all by itself? You're going to cross multiply again. Okay? So if that is the case, if it makes it easier to see by putting that over 1, you can certainly do that. Because a number times a variable gives you what? That number and the variable. So what's 1 times VF? So just the final velocity then. What's that going to equal? Well, if we cross multiplied here, what do we do with these two numbers then? Multiply them as well. 13? 50. You can say it didn't sound right. Okay, 47, and that's meters per second. Okay? So now, yeah, that gives us how fast it was going, but it doesn't give us the distance. But if we have a velocity and a time, what can you solve for now? Yeah, so velocity equals the distance divided by the time. And some of you had done that, and if you did that on your last paper, like I said, that just means you're already ahead of the game. That's a good place to be. Okay? That means you have a really good understanding of this. Okay, so what would we do if this 50.47 equals what? Remember, we got this. Okay? So there's our velocity. We just solved for it. So what goes on top here? Yeah, our depth, our distance, because we don't know that. Then what would go on the bottom? Okay? So again, we can cross multiply. What's 1 times d? And then what would you do with them two numbers? Oh, nope, that's not right. Sorry. The label's wrong. Oh, I thought I heard 159. That's what happens when you get old. You might be thinking, maybe he did fall down and hit his head. Okay? 0.92 meters now, not meters per second. Okay. All right. So when we get to that short evaluation tomorrow, okay? Left outside. Very good. Left outside. Left outside. Left outside. Well, I don't know. What does that mean? Oh, when you say we're not in Hawaii, that's what they do in Hawaii. Yeah, that's right. Okay, so I didn't quite finish the rest of the left outside. Good. Left middle. Left middle. Oh, I see. I can't see that because you're just kind of hiding it down there. Like middle. Right middle. Right outside. Okay. Yahtzee. Has anyone ever got a Yahtzee before? Does anyone even know what a Yahtzee is? Rolling 5 dice and getting the same number 5 times right in the first roll. Okay, so we'll catch up with you next time.